Welcome back to the JMZ Online YouTube channel. Today we are going to be doing a valve job on a 3406B cat cylinder head. To decide whether or not to replace the valve guides, I'm going to be measuring the valve stem clearance using a micrometer and our Mitutoyo split wall bore gauge. Ideally, the guides are straight and within the specified tolerance. However, these guides have significant wear toward the combustion chamber. Since the guides have significant wear, I need to drive them out with the air hammer. With the guides removed, I clean the bore with a wire brush and prep the bore with press fit lubricant. I like to start the guide straight with a rubber dead blow hammer. I'll be driving the new guides in with the air hammer again, so I have found some spacers and shims as a stop to get the guide height set correctly, and to prevent the driver from driving on the thin part of the guide and breaking it. Everything went smoothly with the exception of one guide that I broke because I accidentally angled my driver. So I'm going to have to drive that guide out, order a new one, but in the meantime we're going to move on with the job. Next I had Dad help me get the cat set on the surfacer and I got it fixtured up for the resurface. On my first pass I started with a strong 2.5 thousandths cut. Now, the complicated thing about this head is it is actually longer than the X travel of our surfacer. What that means is in order to surface the entire head, we have to unbolt the fixture partway across the head, and slide the fixture, rebolt the fixture, and continue surfacing. Obviously, to make sure we stay completely flat, I had to thoroughly clean all of the cuttings to make sure nothing would get under the fixture and cause our head to no longer be level. I'm planning on taking a 0.5 thousandths finish cut, so I marked the area between the cylinders that I wanted to stop the machine to slide the fixture. If everything goes as planned, there will be no defects from the fixture slide, but doing it between cylinders makes the transition in a location of the head that the gasket is less likely to have issues. While it may not look by the book, we have never had issues in the past on a head that we did this way. As you can see, the finish cut operation went smoothly, and there is virtually no evidence that the entire head was not surfaced in a single pass. This head was already washed in our spray cabinet once, but for whatever reason, it didn't get as clean as we wanted it to, so I'm going to take a wire wheel and kind of break some of this carbon off. That way when we wash it after all the machine work is done, it'll definitely come clean. I also got a valve guide in to replace the one I broke, so I went ahead and got that installed. Before we can move over to the SERDI to cut the seats, I want to make sure that my new valve guides have the desired valve stem clearance, and that I have a pilot for the SERDI that will fit perfectly. A combination of measuring the guide and using our diamond valve guide hone to fit them to the desired size, while checking against the pilot I wanted to use put us in the right spot. Now we are going to move on to the seats. The intake appear to have a decent amount of wear, but the exhausts are not as bad. I've already checked the valve recession before cutting the seats and anticipate that we will be able to simply recut the seats and still be within the specified limits without costing my customer the extra labor and parts of new seats. To get my cutter set to the correct size, I start by attempting to match the cutter to the existing seat. I can then compare that dimension to my valve, and I decided to bring it back in a bit as I can always move back out after I start cutting, but it is not as easy to move back in if you've cut too big. Matching the cutter to the existing seat gives the best chance of cleaning up the wear without burying the seat too deep. What you see when I start cutting the seat here is that we see the bottom angle come in first, followed by the seat angle and the top angle of the seat. If these were new seats, I would cut each one to the exact same depth. But in the case of salvaging the used seats, we cut each one just enough to clean up the wear. This results in some variation of depth between seats, but it's better than cutting each seat to the depth of the worst one. As always, I vacuum check each seat as I go to make sure they are machined properly. For each cylinder, 2 intake valves share a port and 2 exhaust valves share a port. With some lubrication on the guide to keep the vacuum from escaping between the guide and stem, we can see that our vacuum holds quite well. From my experience, I know that from this quick check, my seats are machined correctly. Moving on to cutting the exhaust seats, my process stays pretty much the same. My preference when running the Surdy is to run the spindle as fast as possible, but sometimes this makes it more likely to chatter. The risk reward is there for me, as I prefer the seats to have the best surface finish possible. Again, we vacuum check the exhaust valves. What you see leaking down here is between the valve stem and the guide. Finally, I have double checked that each seat puts our valves within the specified limits of valve recession. This head has an allowable 48 thousandths valve recession below the deck, and in this case, we were between around 20 thousandths to 30 thousandths on most of the valves, depending on the wear. None of them were close to the specified limit. With my machine work done, I went home for the day, and Dad ran the head through the spray cabinet overnight. In the morning, he thoroughly rinsed the head and blew it out completely. We always try to check every bolt hole thoroughly early in the process, but we both missed 2 exhaust stud holes that were damaged and needed repaired. Luckily, Dad found it before the head left the shop, so there was still time to fix it. One of the holes still had some of the stud left in it from the last time that someone attempted to fix it, but they did not get all of the broken stud out before drilling and tapping it. So our first challenge is chiseling out the half of the stud so that we can get our repair insert back in the correct position. Drill bits tend to wander in a situation like this, so we use the carbide burr in an attempt to remove the final bit of stud at the bottom of the hole. I went ahead and let Dad take the lead on this part because he has a lot more experience with kind of these more challenging bolt removals than I do, so I just wanted to let him take care of it and, take the back seat so that I can learn, but basically get this job out the door. That small piece of bolt at the bottom was basically loose, but it just wouldn't actually come out. So he tried with the drill bit to try and get it to break loose, messed around with the carbide, tried to get it to break loose, and eventually we finally got it.
Loose? Mm-hmm.
So here's a vertical clip of pulling that stud out because I was going to make a TikTok about it, so I forgot to record horizontally.
There it is.
If you want to have any luck of successfully repairing threads like this, you need to make sure you get the entire stud out. Otherwise, you'll be in a situation just like the previous person was, where your drill bit wanders to the softer material of the head instead of staying on center with the hard stud, and you end up with your repair in the wrong position. Given the heavy-duty nature of this application, we are repairing the 2 damaged holes with some solid key locking inserts, so I start by drilling and tapping the holes for the insert. Yes, you do see the tap slip in the drill chuck, but that's because I would rather it slip than be so tight that when it catches, it snaps. Obviously, I always finish by tapping by hand with a bottoming tap to make sure that our threads go all the way to the bottom of the hole. Finally, I went ahead and screwed in the 2 inserts, and I forgot to record it, but there's a little tool that you use to hammer the tabs down in so that it locks it in place. And as you can see now, all of the exhaust studs are straight and in the correct positions. After thoroughly blowing the head out again, we are ready to move on to the assembly, so I've got laid out everything. This head is getting all new Engine Pro valves, SBI rotators, SBI dual springs, SBI keepers, SBI valve stem seals, and we're reusing the OEM locators. When installing valves, I like to run a small bead of assembly lube in the keeper groove of a valve, then dab it onto another valve, and they're both ready to go in so that the guide will be nice and lubricated whenever they get this engine back together. When installing the valve stem seals, I like to dip them quickly in lacquer thinner, which helps them slide onto the guide easily, then they dry quickly so they don't slip back off. On some heads, the spring locator has to go on before the valve stem seal, which I forgot, but I got lucky because on this engine the locator actually fits over the guide with the valve stem seal installed. Finally, I got the valve springs, rotators, and keepers installed using our pneumatic valve spring compressor. This tool is super nice, but it's dang near too small to reach the bottom row of springs on this head. I wanted to take a quick second to say thank you all for watching this far. Your support means a lot to our small family-owned business, and we're excited to have y'all along for the journey. Don't forget to check out the description of this video where you'll find links to our website and our other social media channels, as well as an Amazon affiliate link where you can see the tools we use and recommend to our followers. We do make a small commission on Amazon sales that are made through that link, but we're going to be using that money to improve our videos for our following. Well, that pretty much wraps things up for the rebuild on this 3406B cat head. We will do one last final check of the valve recession and a vacuum check on each of the ports. We don't anticipate anything being wrong at this point since we have checked those things earlier, but it's always easier to fix a problem before it leaves our shop than later on down the road. Thanks for watching. Don't forget to like and subscribe.